non-flaky, then non-wet flaky particle has to pass through the elongation to be called this. It is neither flaky nor elongated. So from the flakiness, we have calculated the flakiness index. From the elongation, we have calculated the elongation index. So the ratio of their weights will give you the flakiness and elongation index. The summation of that will give the combined flakiness and elongation index. The MORTH and the IRC recommend the combined flakiness and elongation index should be within the limits of 35%. Next one is the angularity number. Angularity number basically it tells us a brief idea how angular your aggregate is. You will be agreeing that if a material is rounded, perfect. Suppose you have all aggregates perfectly rounded, it will look good. It will be easy to work upon. You can easily make mix, but there will not be good bonding between binder and the aggregate because it is very smooth. It is not angular. So angularity number basically tells us whether your material is suitable to be used so that it gets a good bonding between the corresponding aggregates and also with the binder. So that's where angularity number comes into the picture. As by the definition, it is the property because it affects the ease of handling a mixture. For example, the workability of concrete or the stability of mixtures, which is relying on the interlocking. If there is not definite or sufficient interlocking, then the material won't be stable. One more thing. If your aggregates get crushed during compaction, then the angularity number test cannot be applied on it because the material is already crushed. So we cannot do angularity number test on it. The apparatus which is required, we need a metal cylinder. Of course, it will be closed and word in one end of 3 liters capacity. Its dimension is 15 centimeter dia, 50 centimeter high. We need a tamping rod as in every test. Balance. A metal scoop is required to fill the aggregates, to transfer the aggregates from metal scoop to the metal cylinder, which we have discussed in the first part. And what we need, trays, oven, basic things. The code has given that this test can be done in this type of pair of sieves. Suppose if you're taking material which is passing through 20 mm, it should retain through 16 mm. It is passing through the 16 mm, it should retain 12.5 mm. Similarly, they have given different sieve sizes on which this test has to be done. This is if your aggregate size doesn't lie in this, like its higher limit is 20 mm. If your aggregate size is larger than 20 mm, then you can't efficiently do it in this 3 liter cylinder. You will need a larger cylinder. And similarly, for smaller, we need a smaller cylinder. But the procedure will be the same. But difference between that, the amount of compactive effect. When we compact a sample, it depends on 3 major factors. If you are compacting it if a tamping rod has different weights, so it is giving different compaction. It is different variable. Another, height of fall. In one, it is falling from means 38 centimeter. Suppose another test, it is falling from 50 centimeter. So they won't be creating the same compaction effect. And third one is the number of blows, which is number speaks for themselves. If you are giving 25 blows and 50 blows, then they will be different. So it is dependent on these 3 factors. You can use a smaller or higher cylinder, but you have to take care of these 3 factors. It is similar to the previously mentioned test, but there is slight difference in which it is also filled in 3 layers, but the number of blows are different. In those tests, the tamping was done at the 25 blows at each layer, but in this case, the tamping is done with the help of the tamping rod for 100 blows at each layer. So we are filling the cylinder in the form of 3 layers, and each row layer is tamped 100 times at the rate of 2 blows per second. And it should be evenly distributed. It should not be like that you are tamping it at only one position. It will create depression on that. It won't give accurate results. So that I am telling it on behalf of every test. The tamping should be done uniformly, not at any single place. So uniform tampation is necessary. So similar tamping is done for the remaining 2 layers. Extra aggregates, what we do, I told you, like we just roll a tamping rod at the surface of the aggregate so that the surface becomes smooth. These are the replicates. It should be in any test. It is better to do some replicates. You should not rely on the only one test. Suppose you are doing abrasion test, you should try at least 3 replicates because these tests are very variable. Depends on the aggregates you have taken. So it is recommended to do 2 to 3 replicates for every test and take the mean of them. So how angularity number is calculated? It is basically 67 minus 100 W divided by C into GA, where symbols have their usual meaning. The meaning is W is the weight of the aggregate in the cylinder you have filled in the 3 layers. C is the weight of water. You fill the same cylinder with the water and take its weight. And GA is the specific gravity of the aggregates you are taking. So